Hi friends, welcome to Unit R, Day 5. In this particular set of notes, we're going to be focusing on simplifying rational expressions, really jumping into what rational expressions are. Rational expressions are when you have an expression divided by another expression, so we have essentially fractions. One of the things that we're going to really hammer home in this first video is simplifying them, and one of the ways that we simplify involves seeing if there's anything that we can factor out. One of the things that I point out in this particular section, the more comfortable and confident you are with factoring, the easier this section is. So let's jump in. Number one, simplifying the rational expression. What we have here is x squared minus 1 over x squared plus 3x plus 2. So x squared minus 1 can be factored into x plus 1 and x minus 1. And then x squared plus 3x plus 2 can be factored into x plus 1 and x plus 2. So what we have here is we have x plus 1 in the numerator and x plus 1 in the denominator. We can cancel both of those out because we're multiplying that entire term by everything else. I want to point off to the side here, the p times r over q times r, you can eliminate out those r's because, again, when you have something divided by itself, it's just 1 to be left with p divided by q. So the idea here is we cancel these out, and we're left with x minus 1 over x plus 2. So that's the only term left. I did not include parentheses. One of the things that I want to point out is we've created a situation where we can't divide by 0 ever. So just pointing it out now, we actually can't divide by or have x being a value of -1 or -2. Now, how did I get those values? Well, if I set what's in the denominator equal to 0 and then solve, not equal to 0 and then solve, because we can't have this value. Same with over here, not equal to 0. Remember, we can't have the denominator be 0. And then solve, we get x cannot equal -1, and x cannot equal -2. So when we talk about restrictions later on, restrictions to values, that's where that's going to come into play. For number 2, we have 6 minus 2x over x squared minus 9. So if I simplify the numerator, looks like I can factor out a 2. I'm going to go ahead and do that. So I have 2, and then in parentheses, 3 minus x. And then in the denominator, we've got x squared minus 9. That's a difference of squares. So I'm going to have x minus 3 and x plus 3. All right, so again, we've got to be careful. This looks like that there's nothing else that we can continue, but that 3 minus x and x minus 3, those look really similar. In fact, what if I factored out a negative sign from this 3 minus x? So what if the numerator now was instead a -2, and then now I'm going to have a -3 plus x? Well, let's see where this takes us. The denominator is still going to be x minus 3 and x plus 3. It doesn't look like anything so far, but let's go ahead and put that x in front. Let's rearrange the order, and you can do that. It's perfectly fine. So I have -2, parentheses, and then if I rearrange these, x is in front, and then minus 3 all over. Ooh, x minus 3x times x plus 3. Oh, look at that. Now I can cancel out or eliminate these. Got so excited that I was going to be canceling out, I put a plus sign there. Can cancel out those, and so I'm left with -2 over x plus 3. When we have a -2, and it's just the only term, we'll generally put that negative symbol in front of the fraction bar, like so. Either is sufficient. And then just to talk about the values of what you can't have, in this example, we could not have x could not equal -3 and 3. I got that by setting my factored denominators not equal to 0 and then solving. For example number 2, to find the product or quotient. To do this, what we're going to do is we're essentially just going to factor as much as possible. So what we have is 2x plus 2 times 3x squared minus x minus 2 all over. So essentially what you're going to do is you're going to factor as much as possible from each set. So let's go ahead and do that. For this first one, I have 2, and if I factor out a 2, I'm left with x plus 1 all over. This denominator here, I can factor out a 3x, and I'm left with 1 minus x. And then times over here, looks like this is a trinomial. I've got factors of 1 and 3, and then factors of 1 and 2. So I'm setting this up using my factoring method that we've talked about in previous sections. The minus sign here, so I'm going to have 1 plus and 1 minus. Looks like what I'm going to have, let's do, if I do a 3 and a 1, and then a 1, let's do a 2 and a 1. Let's see how this turns out. So this gives me 2 and a 3. Oh, really close. I just need to change the signs. So instead I'll make this 3x minus 2 and x plus 1. See if that works. So minus 2. I think I just went backwards. Minus, wait, 3. That's positive 3 minus 2. Oh, uh-oh. Did I have it right the first time? Oh no. So that's plus, that's minus. Negative 3. Yeah, I think I had it right the first time. Sorry about that. X. All right, so if I middle term, minus 3. Yeah, there we go. So that gives me that. And then for this one, this is a difference of squares. This is a 3x plus 2 and a 3x minus 2. One of the things that I noticed, I saw this x minus 1 here, and I saw that this probably could eliminate or cancel with this here, so I kind of checked that. Also, if you get to a situation where you're not quite sure, what you can do is factor everything else out and then see, oh, if this is a 3x plus 2, that's a 3x plus 2. I might be able to cancel those out, eliminate those, so check that. We can cancel or eliminate across boundaries, but I want to point out that this 1 minus x is not the same as x minus 1 unless I factor out a negative. So if I do that, I have a negative 3x and then x minus 1 instead. Because I've changed this completely, I usually put a slash mark through this entire part to show that I've changed it. And then, now that I've started to do a lot of simplification, I kind of want to keep everything in order, keep everything in line. So what I'm going to do is, I'm going to take the 3x plus 2, 3x plus 2, those cancel. This x minus 1 and this x minus 1 cancels. And it looks like that's all. So I'm going to be left with, in my numerator, I've got 2 and x plus 1 over negative 3x times 3x minus 2. So to get what x does not equal for these, we have to take all of our terms in our denominator and set them not equal to 0, then solve. For these two, it's pretty easy. This one is going to be x cannot equal 0. Equal 0. For that one, it's going to be x cannot equal 1. For the other ones, if I set it equal to 0 and then simplify or solve, see, I'm going to subtract 2 from both sides and then divide by 3. Add 2 and divide by 3. So this is going to be plus and minus 2/3. If this does not sink in yet, don't worry. This is not something that we're really focusing on this section. This part right here is what we're really focusing on. And then for my last one here, whenever we have division, remember when you divide with a fraction, you have to multiply by the reciprocal. So I'm going to be flipping, multiplying by the reciprocal. So when I do that, I need to actually take this 10m squared minus 15m and m squared plus 4m minus 21. I need to multiply by the reciprocal. So we're just actually going to set up this problem by rewriting it in its entirety. 4m cubed minus 12m squared plus 9m all over m squared minus 49, and then times m squared plus 4m minus 21 all over 10m squared minus 15m. All right, now going through and working through this, I'm going to find the factors of this first one, so I'm going to factor it completely. Looks like I can pull out an m from all of that, and I'm left with 4m squared minus 12m plus 9. The denominator looks like a difference of squares. That's going to be an m plus 7 and an m minus 7. Times over here, looks like I've got m plus, looks like 7, and then m minus 3. Again, factoring out the m squared plus 4m minus 21. And then the denominator looks like I can factor out a 5m, and I'm left with 2m minus 3. All right. Again, it looks like I can factor this 4m squared minus 12m plus 9. That looks like a square of differences. So that's going to give me equals m. And let's see, that's going to be 2m plus 3. Sorry, 2m minus 3. Excuse me, 2m minus 3. And then another 2m minus 3. And then another 2m minus 3. There we go. Then in the denominator, I've got an m plus 7, an n minus 7. And over here, everything else carries. M plus 3 times n minus 3 over 5n and 2n minus 3. So again, grabbing another color to keep track of everything I cancel. When I cancel or eliminate, I notice that I have an m here. This is going to eliminate just that m there, not the 5. The 5 is the coefficient. It does not get canceled. I have a 2m minus 3 that I can eliminate here. I cannot eliminate both, just one. And then this m plus 7 can eliminate with this m plus 7 here. And then I'm left with just these terms. So I am left with, looks like 2m minus 3 times m minus 3 in the numerator. And then in the denominator, I'm left with a 5. Don't forget that 5. And then an m minus 7. And then my values that I can't have for m. M cannot be, m cannot equal. Looks like I've got m cannot equal plus or minus 7, because then that would give me a 0 for this part. And then I also can't have m equal, looks like I can't have m equal 0 or 3/2. Again, we'll be talking about that in the next part. Join me in the next video where we finish going over some of the examples. Bye!